Good morning, everyone, and welcome to today's webinar. Thank you for joining us for this session entitled SudWaMa Sustainable Water Management, Innovation and Citizen Engagement for Sustainable Water Management. My name is Aida de la Cruz, Project Coordinator of Citizien Fundazioa, coordinator of this project, and I will be hosting today's session. So one is, sorry. Okay. So before we begin, I would like to introduce the SudWaMa project, which provides the framework for today's webinar. SudWaMa is a transnational project co-funded by the Interreg Sudoe Programme, bringing together partners from Spain, France, and Portugal. The project responds to one of the major challenges facing Southern Europe, increasing water stress caused by climate change, urban growth, and regulatory fragmentation. So today's the webinar is part of SudWaMa's dissemination and engagement activities. So I'm doing it. And during the next 90 minutes, more or less, we will explore innovative technologies for water management in buildings, as well as innovative initiatives with high impact potential in public strategies. Okay, so we'll start from the beginning. So I have a document to share. I'll check just a moment. Okay, you can see the document, the presentation.
Not yet.
Not yet?
No.
Okay, just a moment. Because sometimes if I will check on the.
Yeah, it's okay now.
It's okay now? Okay, because if I share, I can't see you, so please tell me if there is something wrong with that. Okay. Okay, so before we move on the main sessions and the rest of the speakers, I present you a little bit the SudWaMa project. As we said, it's the Sudoe Sustainable Water Management, a transnational project from the program Interreg Sudoe Programme. And in that case, we participate 9 partner organizations from Spain, France, and Portugal. And you can see all the entities that you are working in that project. And as we said, the challenge is more or less water scarcity and urban water resilience. Okay, so an image to enter in the topic. Okay. So climate change and extreme weather events such as prolonged droughts and intensive rainfall are putting growing pressure on water resources. At the same time, urban and economic development is increasing water demand, while regulatory fragmentation and low public acceptance of reduced solutions continue to limit innovation. So these combined challenges make it clear that traditional water management approaches are no longer sufficient. So what is needed is a more integrated or circular and participatory model of water management. And this is where SudWaMa comes, and the project proposes a holistic strategy for urban water resilience, combining policy and governance, technological innovation, and citizen engagement. And the SudWaMa project is structured around 3 main pillars that you can see in the image. I make a summary, and I will describe a little bit more. The first pillar focuses on strategy and policy. The objective here is to develop a joint Sudoe strategy for circular water management, harmonizing regulations, public policy, and best practices across regions. That it's important that because we are working in the Sudoe territory. And this work aims to support public authorities and decision makers in adopting coordinated and effective water management strategies. So in that case, for the Sudoe program, that is the best important work that try to implant this kind of strategies that we will work in the project. The second pillar is the technology and innovation. In that case, these innovative water solutions are being implemented and validated, or we are working on that in real life environments, including institutional buildings and urban settings. And these solutions cover areas such as rainwater, green water use, sustainable urban drainage systems, and closed loop water and waste or black water systems. To achieve this, the project is working through four complementary living labs located in France, Portugal, and Spain. And you can see in the map where are we located also, the pilot sites. And each addressing specific local challenges while contributing to a shared international vision. So the idea is to each pilot they will work in different aspects as we said, and after of course there will be some transnational or topics that we can compare and we can apply after this analysis. So during these pilots working while we are working this pilot, we will see what are the things that we can find similar, different, we can compare, we can work together, and all this thing. And the third pillar focuses on engagement and education. And in that case, people at the center, SudWaMa places people in the center of the transition towards sustainable water management through water living labs and digital training modules, public awareness campaigns, and citizen science initiatives. The project empowers users, professionals, and institutions to participate in water saving practices and long-term behavioral change. So we think that is a very important aspect in our project also. SudWaMa is not only about testing solutions, also we will to create impact with this project. So the project aims to deliver a replicable and scalable model that integrates technology, policy, and public engagement. So its legacy includes a joint Sudoe strategy for circular water management, validated pilot solutions, and strengthened institutional capacity to implement sustainable practices beyond the project's lifetime. I think that's more, we think that maybe is the more difficult aspect, but we will work on that. In this context, today's webinar is part of SudWaMa's dissemination and engagement activities, as we said, and it provides a platform to share innovative technological solutions and high-impact public strategies, and to foster dialogue between experts, institutions, and practitioners working in the field of water management. So, for the moment, and with this introduction, I think that only to have a little bit of information of the SudWaMa project, I think it's enough. If you need more information, you can ask us or take in contact with us. And I would like now to move on today's agenda and start with the first session with the first speakers. Okay, this is the milestone that we have a lot of months to work in the project for the moment. Okay, so we can continue. Okay, with the first speakers. I would like to introduce you, Mr. Pascual Ferrans, project specialist engineer at Green Blue Management TIPSA Group. Okay, so Mr. Ferrans.
Yes.
Okay, thank you.
Hi, everybody. Are you listening quite well to me? Okay.
Perfect.
So I guess I can share my screen now. I will share it.
Yes.
Yes, okay. So I'm guessing you're already watching my screen?
Yes, perfect.
Okay, perfect. Well, good morning, everybody. First of all, thank you very much for inviting us to give this small presentation, which I think is quite well in the way of what you were saying about the introduction of the idea of this event. So I'm hoping that we can give some information which can be valuable for the project. So my name is Pascual Ferranz. I'm a PhD in environmental engineering, and I work as a project specialist engineer in Green Blue Management, which is a company part from the TIPSA group, which is a Spanish company. We're based in Valencia, in Spain. So what I would like to talk about in today's session is about sustainable urban drainage systems. Some of you might have heard about them, and how they can enhance urban resilience and transformation, not only in buildings, but I would like to also make a focus on urban spaces in general. So yeah, this is a small table of content of the topics that I would like to talk about today. So first, I would like to go briefly about how urbanization may bring problems and challenges for urban drainage management. And then I would like to introduce a concept which has different names, but at the end, I would like to talk about sponge cities and how they mean a change of paradigm when we're talking about rainfall water in cities. And then a small presentation or just some examples about success stories, mainly here in Spain, which is our based area of where we work. So talking about problems and challenges that urban drainage may bring, here's a small diagram of how precipitation might be changed in urban areas. So on the left hand side, you can see a diagram of how a natural area should look. If we're talking about the water cycle and the different aspects of how water is treated when it rains. So in the natural area, you can see here that most of the water that comes in a natural area would go to evapotranspiration, and also to infiltration, shallow or deep infiltration, more 50% and 40%, and only 10%. This is like big numbers, but just to make the point that I want to make, just a small percentage of the water that actually precipitates in natural areas will be runoff, which means like water that goes on the surface. What happened when we start sealing the soil? The imperviousness increases in urban areas, and in the long term, this can have big challenges, which can be translated into increased peak flows, increased runoff volumes, and shortened concentration times. If we see the reasons behind these increases, what was before 50, 40, and 50% of the water that precipitates, now in cities we have that most of the water that precipitates will be runoff, which we will have to handle in some way. This runoff will in turn generate these different problems that we have to address somehow. So these are just some examples of the challenges that may bring the water management in urban areas. So we can have insufficient network capacity, and this will, in the long term, this will make the network insufficient, and we will have to make it bigger. Pluvial flooding, this will, and every time more and more, these kind of pictures is more recurrent, due to different climate change scenarios that we can talk a little bit more later on the presentation. But this will also bring pluvial flooding, and in the long term, this will also mean high energy consumptions, pumping, treatment, and this of course will also mean like high budgets for treating the water, if we don't treat the water right in urban areas. So I would like to make just a quick example of, depending on how we treat water, how the sewer system works in our city, the impacts that urbanization may have. So in this first example, which is a combined sewer system, we can see here on the left that in the dry weather, what should happen is that the sewer, the pluvial residual water from buildings and gray and black water mainly, will go to the treatment plant, and it shouldn't have much problem. The problem comes when we have wet weather. Our network doesn't have enough capacity to treat all water, and this will generate what in the field is known as combined sewer overflow, CSOs, which may have big environmental consequences on the rivers, sea, and in general on the receiving water body. And what happens if we have a separate storm sewer event? Well, this is kind of different. Here on the right, you can see what happens when when we're in dry weather, when there is no rain. What should happen is that all the residual water that comes from buildings and from human activities in general should go to the water treatment plants. But what happens when we have wet weather is that most of the water will go directly to the river or to the water body that is receiving water. And this, you may think that rainwater is not polluted, but this is definitely not right. And no, this is not like this. So on the right hand side, you can see a small. This is from an experiment that we performed in GVM. So just for you to see that this is from an event in an urban area, and just by the color you can see how polluted rainwater may be. So this is also a big problem for the receiving media and water bodies. Just some examples of some other challenges that may bring the rainwater in cities. You can see here on the left some risk and some areas that should be used for citizens, like green areas. You can see here a lot of erosion. Here you can also see some floodings that will make that the green areas that are supposed to be usable where they're not. And also for the vegetation, I want you to see this image because later on we'll see some comparison of how we believe that this should be changed. So we will also have a limited space for vegetation, and you can also see here how we can have safety risks for citizens, not only because of the flooding, but because of those some uneven surfaces that may bring unsafety for citizens. So having this in mind, I would like to introduce now some of the concepts that we work in GVM, which in the long term is called sponge cities, and how it should be accompanied with a paradigm shift of how we treat water in cities. So what we propose, what we think it should happen is that we should move forward to smart water sensitive cities or sponge cities. Sponge cities, I like this term because it's quite understandable that what we want to do is to absorb and to use the water that comes in the city. So these concepts, the idea behind these concepts is that we mimic natural processes to deliver benefits without harming the environment. There are different pillars that integrate this idea, but in the long term, what we want to do is to integrate urban development with water management. So some of the ideas that we want to change or introduce with this concept is that we treat cities as water supply catchments to see the water as a resource that we can use and not as a waste that we have to evacuate as quick as possible, which is how I think it's done in most of the cities right now. And also because of the green areas, we believe the city can provide ecosystem services and increase their livability for the citizens. So you will have some added value with these solutions. And also it's very important that cities have engaged communities and committed institutions to have this change of paradigm of how we treat water in cities. So this is just a small example. You can like visually see how a sponge city should look, and some concepts. I don't want to go very deep on these concepts, but some ideas that would like to see here. For example, in this area, we would like to enhance infiltration. If you remember the first diagram that we saw, where infiltration was a problem in the urban water cycle diagram. Well, we want to enhance infiltration, we want to enhance water storage, water drainage, and even some strategies for to enhance water retention. And in the long term, the idea is to have a nice city which looks very nice, but also treats water in a smart way. So in order to change this paradigm, what we believe that is a great and very powerful tool to do this is our SUDS, which is the acronym for Sustainable Urban Drainage Systems. Usually, or what you may think is that SUDS have, of course, a big one of the pillars where it stands is the quantity. How these structures can manage the quantity and the run of production in terms of volumes and flows. But also there are three pillars which are the same as important as the first one, and is that these structures can also give us some management of runoff pollution and on water quality, and same as is important the other two pillars in which those stands here, that they create and maintain better urban environments, and they should create and enhance also better natural environments in accordance with the urban environments and having a mixture of both. So these are the four pillars that we use to design these structures. And as I was saying, each of them is as important as the other one. So there are different definitions on SOTs. Also, there is different ways of calling it depending on the place of the world. They can be called low impact development SOTs. Well, they have different acronyms, but at the end, we're talking about the same structures, or not the structures, but idea of how to treat water. So one of the definitions is that SOTs are an innovative stormwater management and urban planning, and this is very important, the urban planning strategy aimed at replicating and restoring pre-development the hydrological processes. You remember the first diagram that we saw. And the idea behind this is that they strategically integrate runoff control measurement with urban landscapes. So this is just one example. If you see this, you may believe that okay, this is a nice street. They have gardens, they have flowers, they have green areas. But what if these green areas they also help us to treat stormwater in a smart way in the city? So this is the idea behind it. So some key ideas about SOT's philosophy and how this work. We're aiming to protect existing water bodies by treating the quality of the runoff. We want to preserve natural drainage patterns. We're talking and the same about pre-development hydrological conditions. We want to minimize and disconnect impervious surfaces. We will see some examples on how we can manage and achieve this. This is also very important, and I think in terms of the project in general, this is one of the main potential that SOTs have, is that they consider the rainwater harvesting and reuse strategies in order to have the circular economy concept. So that's another idea and key goals of SOTs. We can see how they will help us to bring rainwater at the source. We will see some examples later on also. And the key idea of these structures, these are some structures. We will see some examples in the next slide. But I want you to keep also the idea that this is what we aim to do is to have management trains with different interconnected structures, not just one structure with potential will be will have higher impacts on the treatment that we do. Of course, we are aiming to reduce the flood risk and have multifunctional landscapes and with different purposes and multiple co-benefits. I don't want to go too deep inside this concept, but just to mention some of them. I don't know if you have heard the effect of the heat island effect, but it's basically that in previous area increased temperature in cities, and these kind of strategies will help us to mitigate this kind of negative effects, not only on water but in different holistic areas. So these are some examples for you to understand how this concept that we're talking about, we can bring it to some structures or typologies, how we call it. So maybe green roofs, you have heard maybe about those is having vegetation and so filtering media on the roofs of the buildings. But this is just one example. We also have rain gardens or bio retention zones, which are close by the pedestrian zones or even the vehicular roads, and they can treat the runoff quite efficiently. Infiltration trenches in parking spots and parking places where you can also have different filtering media. Vegetated swales. This is one of the important concepts that I would like to talk a moment. Is that what if we transport the water in a swale which have vegetation will may look good, and this is mainly for transportation purposes. So this is how we start to see how stuff typologies may have different focuses. If we're talking about this, we're talking about high treatment purposes. This is for transportation. Remember also the first picture that we were seeing on how bad managed trees in cities may have on safety implications. Well, we can also have some structures to manage water and to avoid this kind of problems. Permeable pavements. This is also a very high potential such typologies that is being nowadays used in different context. Filter drains, there are different kind of typologies. Detention and infiltration ponds, we'll see some examples, but you can see it here to temporarily detain and retain water. And if we go to the big scale, so there is also different kind of structures depending on the geographical or the spatial scale that we're talking about. But we also can have this kind of structure, which is at a watershed or big scale. And we can construct natural structures like wetlands and ponds in order to have treatment and high scale management in cities. As important as these are, there is also another concept, which if we think about it, this kind of events that we are right now is also very important, because as these are structural measures, as important as those, there is the non-structural measures such as educational and programs and citizens participation, dissemination of experiences like this one right now. Legislation on planning, appropriate design, and also a very key factor in this kind of projects, which is the maintenance and prevention practices. So the idea behind this is that not only building structures is necessary to achieve sustainable water management in cities, but these measures are also very necessary and included within the concept on the definition of SUDs. At the end, this is all included within a greater and bigger concept, which is nature-based solutions. So we're talking about actions to protect, sustainably manage, and restore natural or modified ecosystems. And this is also very important. We're also addressing social challenges and providing human well-being and biodiversity benefits. I would like to stop just a minute in this challenges. And here you can see some of the examples of how suits and nature-based solution can address social challenges, such as the climate change mitigation and adaptation, human health, food security, water security. And as this, we have different examples of how this kind of solution address social challenges. And at the end, what we want to provide is human well-being and biodiversity benefits. Some examples about what we mean when we're talking about change of paradigm. Here on the left-hand side, and this is what we were talking about of disconnecting water on the source. So what happens if normally we have this pipeline that will be directly connected to the sewer system? What happens if we disconnect it and then we direct it to a garden that will give us some retention, some treatment of the water? Or what happens if we stop addressing problems with gray solutions, with underground big pipelines, and if we start to enhance superficial structures such as this to treat water? Or what happened, we just finished last year a very nice project about a SOTS actuation in Catalonia, which was based in a roundabout. So what happens if we stop having these high quote roundabouts, and if we start depressing the structures to have structures to treat water efficiently? Or what happens, and this is also an example of the big scale structures that we may also have. What happens if we stop having these big rain harvest deposits, and if we start some superficial structures such as which will also provide some nice and green areas for the citizens to take advantage of. So these structures are designed to be dry most of the time. So why don't we change this idea of how we treat water with green for structure superficial? This is also another key aspect. And normally how these projects work is that we have some budget and we have the water utilities company and they take the decisions. But what we are talking about here and with this change of paradigm is that what happens if the university and academia are involved? What happens if the green spaces are involved? What happens if the energy or even the community, which is also very important, is involved? And we change how water projects are usually managed, and we start treating projects in a holistic way where different stakeholders are involved. Okay, just the last aspect of the presentation, I wanted to make some success stories. So this I want to start just to give you an idea with some success stories in Washington D.C. This is in the United States of America, which is one of the countries that have been implementing these kind of technologies. Also with probably the UK, Australia, also China. But I wanted to make this as the first examples of these structures, so you may see how they receive water from the roads, from different depressed green areas. But what I wanted to do is this. Usually, you may think that this is some technology that is not used, at least in Spain right now, but that is not true. We have had some experience in implementing this kind of projects in Spain. So these are some examples of, for example, this is in Barcelona, in a social housing development in Barcelona. So we design a holistic strategy to treat water with different green structures. This is the project well conceived and finished. Also in Barcelona for treating water from different roads in the neighborhood of Bon Pastor. This is another good example of how projects have been implemented in Spain. Also in Barcelona, and I wanted to bring this not just because of the award, but to make the concept clear of how you should manage this in treatment rates. So here we have different structures from the source of the runoff, which are the roofs of the buildings, but also these are interconnected with these structures, and then with an intermediate deposit which is then led to a reticular big deposit, which is also connected with an infiltration basin. So this is a nice example on how this should be treated as treatment drains or chains with different structures interconnected. This is another very nice example also of implementation of such in Spain. This is, well, you may or may not like the Atletico Madrid, but this is one of the important projects that we have worked in Spain, which was the installation of several hundreds of square meters of permeable pavement, which you can see here. If one day you have the opportunity to go to this stadium, you may see that this is already implemented and it's been working quite well for some time already. This is another very nice example. I wanted to bring this because it's a very big area. It's an exhibition center in Fuenlabrada in Madrid, in Spain. And this is also a nice example of how all these structures are all interconnected within them, with different typologies, with different strategies, with different ways of connecting one superficially with the other. And at the end, we can completely treat the rainwater of this exhibition center will have several hectares of superficial area. And this is another example in Valencia where we are based with different typologies and also with the non-structural measures, which is the one that you can see here, with the guide for designing SOTs for Valencia. And this is also another example of how non-structural measures are important. So we have also worked with in Reus, and not only in the project for the roundabout that I told you about, but also in Reus, we have the opportunity to work in the preparation of the master plan for sustainable urban drainage systems, which is the step by step of how SUDs may be implemented and enhanced in all the municipal area of Reus in Catalonia. We did something similar in Pamplona. And I don't know if I have some other examples. No, these two examples I wanted to bring in just to give you some ideas on how this is, how the non-structural measures are also very important on implementing these kind of structures. So that was all. Just final thoughts about the presentation and how should be conceived. So SUDs can be implemented in a wide range of projects, and they are already well established in Spain. They should be addressed from a multidisciplinary and multi-criteria perspective. And this is very important also for you to implement in a very straightforward way. It should be considered in the early stages of different projects, from planning and design. It's very important to have local design guidelines and these non-structural measures that I was telling you about to standardize the design of these kind of structures. And there is always multiple solutions even for the same problem. So idea is to analyze in a holistic way with different stakeholders each problem, and to be able to address the problem in the most sustainable and efficient way. So I think that was all for me. So thank you very much for your attention.
Yes. Thank you very much, Pascual. It's very interesting presentation. So thank you very much. So now we can continue with the next presentations. And for that, I introduce you Mr. Matthew Asley, General Director at Coupo France, who will present complementary perspective and practical experiences. So, Monsieur Asley, your
Yes.
turn.
Hello, everybody. Good Deneri. Thank you very much for welcoming me. I'm sharing my screen. In a few seconds. Okay, I hope it's okay for you. So,
Perfect.
Copo is a kind of specific company as we are driving by purpose. Our purpose is to preserve our water, our communal water, and we are doing it by the cooperation. How it works. So first of all, we have five groups that are together driven our communal company, and we are doing it by activating three levers. The first one is to propose the best water solutions. The second lever is to co-design and innovate, and the third lever is to bring together the voice of the water. So briefly, just would like to show you some of the solutions we have as partners. They are in three categories. The first one is pedagogy, and we used to work with the Water Family, which is in a French NGO, and Sato, which is a startup. Both of them are helping us to propose pedagogy for children, for adults, from the operator, the technician, to the main leader and politicians. We have solution in presential or by network, not by network, but by digital. Second kind of solutions are services. One of our main partners is Architoria, which is a technical studying desk, which is able to work as an architect to calculate and design the main solution for an hydro performance building. The second one is L'Échappée Verte, which used to design, let's say, the fields and the ground to be able to generate and catch the water. And the third group is what we can call product or technical solutions. Fluid is a solution of non-intrusive measurement to measure liquid flows. H2O care and Hydroloop is a solution to catch the gray waters and filter them to put them back to, by example, toilets, or by example, for the washing machine. And Juin is a technical solution that offers some, let's say, water preservations by using less and less water in the way to wash your foot at the beach. So just note that we aggregate solutions, several kinds of solutions, but I have a question for you. According to you, what is the very first step to preserve the water? I'll let you a couple of seconds to think about this simple question.
Not consume it.
For sure, that's a good solution for sure. But I've got for you another solution, another way to think. For us, the very first step to preserve the water is to mastering our understanding of the water usages. Who consumes what, for which uses, in which proportions, with what impact, on which territories, in what water context, and so on. Lord Kelvin used to say we will manage only what we measure. But to be clear and to be honest, to our understanding, today we used to work with, let's say, a lot of data that are measured with a lot of solutions in a lot of framework and so on. So these data are unclear, maybe not up to date and not comparable. So it's a real difficulty today to well address the water issues. That's one of our purposes. We would like to masterize and to offer the global and the entire visualization of the water data to together improve our way to act. That's why within 2 years with Architoya, we developed one common framework that evaluates the water performance of the buildings and their ground, their fields. We call it DPH in French, which is a kind of water performance diagnostic. It could remember you the DPE, which is a framework for the Europe for the energy performance. So DPH is at the water what DPE is for the energy. The first common framework that value the water performance. We target everybody, companies, public entities, and citizens. For all of them, one of the issues is, let's say, the budget of the water. For company, the main interest is to improve their robustness. Any kind of economic model is linked to the water issues, price and availability. So we can work with the companies to improve their robustness to face these issues. For the public entities, the topic is the climate adaptation and the services continuity. So we work with them to fix these issues. How it works? What are the main premises of the DPH? First of all, is to offer a readable and a comparable water score from A to G. So for a child, for a grandmother, a grandfather, and so on, it's really easy, thanks to our reports, to understand if the building is or not hydro performance. Second big promise is to propose the top priorities for the best action plan. And we are targeting to offer until 40% of water saved for each DPH. As a cooperative company, we have another promise. We would like to offer to the politicians and public authorities our data. How it works? For sure, we have a global score from A to G, but this global score is calculated on 5, let's say, indexes. First of all, the quantitative index. We are looking at the flows that are engaged in the field, in the building, and in each of their usages. What are the incoming flows, what are the volumes, and the quantity control processes. So this index has its own notes, in its own score. Then we are looking at the qualitative index. We are looking at the outgoing flows of the field, the building, and the machines or devices. And we are looking at the, let's say, the fact that in that flows, we have or not some chemical or organic inputs. Do we have some filters and do we have some recycling technology and flows? Third index is about the equipment and the usages. I used to take the same example each time. In your shower, you can have a device that is a performance device to reduce the quantity of the water you use during your shower. But if you stay maybe 8, 10, or 12 minutes in your shower, even if your device is a good device, you have bad usage. So we are always looking at the device and the usage. In a company, we will have a look at the water strategy. Those have the company any target in terms of reducing the water they use for within the next 2 years, 5 years, or 10 years, and so on. The fourth index is surface biotope coefficient. It's close to what Pasquale proposed a few minutes ago. We are looking at the area, at the field, at the building, even at the rooftop, to measure how far these things are or not still permeable and still in accordance with biodiversity and the big water cycle. And we give a score. And the last index is the water stress index that measure the needs and the stock we have at present in 2026, and then in 2030 and 2050. These 5 index have their own notes, and these 5 notes give the global score. Day by day, how it works, we used to do a pre-visit, especially if the building is with a complex process. We send a pre-survey to our customer to collect a lot of data. We realize our audit. At the D-Day, we are always 2 expert engineers, hydrobiologists, and so on. We measure, we collect data, we are driving some interviews with operator, technicians, and so on. And then we push all these data within our own, let's say, algorithm and tools to create our report. This is an overview of one of our reports. This is the first page, the very first page. Maybe I can zoom for you. And as you can see, it's really easy to read, really clear for everybody, because our target is not to deliver something really complex for just some engineers and so on. We would like to propose such kind of diagnostic to everybody. So it has to be very clear and simple to understand, to accelerate on the water preservation. So on the very first page, you have your global score, the 5 scores for the 5 index, our main conclusions, and an additional index that, let's say, summarize how much water liters are engaged for €1 of turnover. And we compare it to competitors. Thanks to that, the company can understand easily if they use more water than their competitors for the same euro. And then you have 1 page by index, quantitative, qualitative, and so on. And you can see the main figures about the water which is used by the customer. Excuse me, this is in French, but how far it can raise down his usage of the water, what kind of recycling he can do, and so on. You can see the main points of its process, what can he improve, what is already well done by the company, and each time there is a conclusion for the index. So you can see here, as another view, the 5 index. We have theoretically 1 page with our conclusion, and on the bottom right, you have a first macro plan, macro action plan to drive our customer for the improvement. And there is a projection here, a simulation. If he put in place these actions, then its nodes can go from this node to this another node. So this is, let's say, the basic pack for the DPH, which has to be done in a constraint timing with a constraint budget. One more time, I insist on this. Our proposal is to let people do, let's say, to let people access to this kind of diagnostic. We have some additional, let's say, proposition. We can propose some detailed action plan. We work on maybe 30 or 40 action plans or actions usually that we propose to our customer, and he can participate with us to define what are the main action plans he wants to put in front of our diagnostic. We can propose them to put some measurement devices. We can propose them to go on technical feasibility studies. We are able to support them to the on-site implementation, to support them on the establishment of a water strategy, and to support them on the funding research. What you have to understand is that we don't want to do all the diagnostic by ourselves. We are a small team, and as our target is to make this kind of diagnostic accessible to anybody, then we are working as a network, and we are training some people out of our company to become diagnostic assessors. Then the AFNOR group, which is in charge of the normalization, came to us 8 months ago to normalize our method. So probably in 2027, we should have a DPH norm that will help us to, let's say, standardize our way to value the hydro performance. Plus, we propose training and certification for future assessors. They have to pay and keep their annual licenses to maintain their skills, to be sure that in 1 year, 2 years, 3 years, they still will be let's say, able to realize DPH. And we used to work with the main stakeholders of the water issues in France, like CSTB and le ministère de la Transition écologique. To conclude briefly, our purpose is to go from the diagnostic to the pragmatic solutions. We are able to do both of them, diagnostic and solutions. And thanks to that, we contribute to understand systemic issues and act to preserve the water. Thank you very much.
Okay, thank you very much, Mathieu. And continue with these presentations. Now we will start with the next block that is focused in innovative initiatives for defining high impact in public strategies. So for that, we are joined with the next speaker, that is Mr. Diogo Faria de Oliveira from ERSAR, the Portuguese Water Regulation Authority, and advisory board member for PENSAR, the Portuguese Strategic Plan for Water, Sanitation and Drainage. So, Mr. Faria, yes, okay, you are ready.
Thank you. Thank you very much. Good morning, everyone. I'm sharing the screen. Okay, I believe you are seeing the presentation. So this presentation is a little bit different, as the innovative initiatives, they take long, they take a generation. So although we are calling it innovative, it is still high impact public strategies for the Portuguese water sector. So we will briefly go to the Portuguese water sector, then we'll talk about aggregation of utilities, regulation, and final remarks. As you probably know, we entered the European Union in 1986. And for the cohesion of the social and economic standards to the average EU country, the European Union start supporting some sectors here in Portugal as transports and as water and sanitation. So lots of grants was coming from the EU for us to do wastewater treatment plants, to extend the network, and so on. But here in Portugal, municipalities had the responsibility of doing it. So each municipality had its own priorities. Some did some wastewater treatment plants, other extended network, and so on. And our indicators were really poor. For example, wastewater treatment, we had only 28% of coverage here in Portugal. What happened is that because municipalities were choosing to do their investment, many wastewater treatment plants didn't even ever worked in their life, either because they were badly designed and constructed, or because there was no sewage connections, or just because the municipalities couldn't operate. So the EU told us that we had to do some reforms, otherwise they will not put more grants in Portugal. And this triggered the reforms that we had to go in this country. These reforms started in 1993, and we have done changes in laws. We have done aggregation of utilities, restructure the tariffs, and rethink the sustainability of our water supply and sanitation. So in the laws, we have made only little small changes, but these changes were key to change the entire sector. So one of the changes was to enable the central government to partner with the municipalities. Although this is a municipal responsibility, the government could do these partnerships with the municipalities, 100% public, but with the government participating with 51% in these partnerships, and the municipalities the other 49%. The second change was about private sector participation. Here in Portugal, privatizing water and sanitation is absolutely forbidden. But there was this little change in the law that said that the private sector could enter into concessions with the municipality. So these two minor articles made all the difference for the changes here in Portugal. The first one was to create the so-called multi-municipal systems. They are basically public-public partnerships, okay, public concessions, 100%, for bulk services, to do water treatment plants and wastewater treatment plants in these partnerships with the government. So the government entered with a partnership with the municipalities. They do this public company, and they removed the responsibility of the municipalities of doing water and wastewater treatment plants, okay? Downstream, at the distribution systems, we call it retail systems, still the municipalities could choose to either do it alone or do it with the private sector. In terms of tariff, we have a full cost recovery in theory, and I'm going to explain it better, for tariffs. So tariffs include the bulk water tariff, what the customers pay to these bulk water companies, these multi-municipal companies, and it includes the retail operation tariff, the price that the municipalities retain for themselves to pay water distribution. Here in Portugal, tariffs are affordable everywhere, okay? We pay on total by water and sanitation 2.32 euros per cubic meter. And still, if the vulnerable groups, the low-income families, and families that need support, they can go to a scheme of social tariffs. Here, municipalities can apply them or not. Again, it's volunteer on their side, and we have social tariffs in 77% of the municipalities here in Portugal. Then we made some changes in the technical solutions as well. We have decided at the time to save the groundwater for emergency, for water scarcity periods and for emergency. And we have decided to make all water supply and sanitation by surface water, okay? What does this mean? This means that in Portugal, 45% of the country which is based in Oporto in the north, in Lisbon in the center, and in Algarve in the south. They are supplied with only 5 water treatment plants. So only 5 water treatment plants, 2 in Oporto, 1 for Lisbon, and 2 in Algarve, supply 45% of the population. The remaining population, the rural population, went to a second generation of multi-municipal systems. So we started to do it in large urban areas to have high impact, because here was where the population was centered. And then when we have finished Porto, Algarve, and Lisbon, we went to the remaining country, okay? So these were the reforms that we were performing. Also, along with the reforms, we have done national strategy plans for water and sanitation every 7 years, okay? That we presented to the European Union, and we explain what we have done in the previous 7 years and what we want to do in the next 7 years. And we agree with the European Union and with the financial partners what we needed for the next 7 years. So they were focused on different aspects. For example, the first one was focused on urban areas, the first multi-municipal systems. The second one, between 2007 and 2013, was focused on the second generation multi-municipal systems. The third one focused on efficiency, and now we have a fourth one where we include also rainwater management, okay? So these are very important to align stakeholders on one hand and to attract funding for the country on the other hand, both from the EU, from the European Investment Bank, and from other financial partners. With this, we have invested CapEx alone 40 billion euros in the country to completely change the scenario of water supply and sanitation, okay? So we are 10 million people. It's a very easy benchmark. It's 40 billion euros for 10 million people, okay? So this was a huge investment done as blended finance. This means that it has grants from the EU, it has subsidies from the state, it has the private sector operators directly from PPPs, and it has commercial banking from bonds and loans. The remaining finance came directly from the tariffs for those that were already financially sustainable. So how are we organized? Basically, the municipalities still decide what they want to do with their systems, okay? They can partnership with this public governmental company called Águas de Portugal, or they can go alone by themselves, or they can go by public-private partnerships, okay? So they have a large spectrum of management models that they can choose, okay? The ones that don't want PPPs, they put it aside. They can go with the government or by themselves. Also, we have 2 authorities. One environmental authority called the Portuguese Environment Agency that is responsible for licensing water catchments and for licensing wastewater discharges, okay? And we have a sector regulator called ERSAR, which does the water supply and sanitation regulation. This said, I'm going to go a little bit deeper on aggregation of utilities. So, as I told you, there is this government-owned company called Águas de Portugal. It owns 100% EPAL, which is the company that does the distribution of water in Lisbon and there's the bulk systems for the metropolitan area of Lisbon. And then they have these 12 multi-municipal systems throughout the country where they participate with 51% with the shares and the municipalities with the remaining 49%. Okay, so this is our country. It still has some, as you can see here, some white holes, okay? These are the municipalities that choose not to partner with Águas de Portugal. So the country by now looks like a little bit, you know, those Swiss cheese full of holes, okay? So it's like Portugal. Portugal is like a Swiss cheese. It has some holes in it, and these holes represent the municipalities that are not partnering with Águas de Portugal. On the distribution systems, so the retail systems, there were also some aggregation, but very few. One in 1997, then one in 2009, one in 2015, and all of a sudden, many municipalities start to aggregate their systems. Why? Because the government put a financial incentive for aggregation. They gave grants to the municipalities that aggregated their systems to gain scale, okay? Regional scale. So this is very recent, and it was possible through this incentive scheme made available for the municipalities. About regulation. So when we started these reforms, we have created this national observatory. It was only an observatory for concessions, both the multi-municipal concessions and PPPs. Then it evolved, and basically the regulator here in Portugal evolved with the market, okay? The more mature was the market, the more mature was the regulator. So from the observatory, we have created an institution, again, just for concessions. Then we added the quality of water to all utilities, public and private, okay? And then we started regulating all utilities, okay? In 2009. Then from an institute, it went into an independent authority under the parliament and not under the ministries. So by now we have a regulation, an authority that responds to the parliament, and it has several regulatory functions. It is a very powerful regulator here in Portugal. It introduces confidence to the consumers, introduces confidence to the investors, and introduces transparency to everyone. So my final remarks: these public policies and reforms helped us to come from drinking water safety from 50% in 1993, as I show you in the first slide, to universal safe drinking water quality, okay? I have two daughters, and my daughters drink from water taps. So I know what I'm saying, and I give it to my daughters. It's absolutely safe all over the country. The network coverage is now universal. It only does not cover, you know, the farms and detached small farms and big farms, basically. With the wastewater treatment that increased from 28% to 86%, we were able to have this coastal bathing quality, which is very important for the Portuguese tourism. You can bath in all qualified beaches here in Portugal, both from the ocean and from the river as well. So this is it. What can we learn from these reforms? So first of all, it is important to introduce reforms when you cannot respond with quality services and with quality products. These reforms introduced trustworthiness from the EU and from financial partners, and creditworthiness as well. This is how we were able to invest 40 billion euros. Okay, the strategy plans, they helped a lot to align all stakeholders and to define what to do in every 7-year period. Okay. The aggregation of bulk services allowed us to comply with the Urban Wastewater Treatment Directive and the Drinking Water Directive, whereas at the same time removing the burden of that heavy investment from the municipalities. The aggregation of retail services, it helps creating scale and more financial sustainable utilities. And the strong regulator introduces transparency, which is very good, again, for the confidence in the market. So we are still moving to full cost recovery. There are still some public utilities that have to be subsidized, but the bottom message is that these things take time. Okay, you cannot do such huge reforms in a 5-year period, not even in a 10-year period. It took us a generation to arrive here. Okay, so thank you very much. This is all. Thank you.
Okay, thank you very much. All of them are very interesting presentations. So in that moment, we are now approaching to the end of today's webinar. So I would like we can open a space to some questions and answer whatever. So if someone has any question, then we have time for that. I don't know if there is someone. Not for the moment. Okay. Then sometimes we need time to process all the information. So it's better to assimilate all the information, review the videos, and after if someone has any question or they want to contact with the speaker or to ask them, they can do that. So thank you very much all the speakers for your valuable contribution, and all the participants also for joining us. And this webinar is just one of a lot of webinars that we must to do during the SudWaMa project. So this is a way, a journey, more or less, to a more sustainable, resilient, and participatory water management in these territories. So thank you very much, and we look forward to staying in touch through the SudWaMa project or in another webinar. Okay, so thank you very much, and have a nice day. Mil esker denoi.
Thank you.
Obrigado, muito obrigado.
Thank you very much.
Merci beaucoup.
Agur.
Agur, Leister arte.
Thank you so much.
Thank you. Bye.
Thank you very much.